Learning never stops and it is up for grabs. Good day, learners! Join me as I guide you every step of the way in learning mathematics the fun way. Students, be ready with your lecture notebook for note-taking if necessary, and your module for reference. Are you ready? Let's start. Our topic for this session is about the language of sets. Before we go over to the activity, let us be guided with the learning competency. In this module, you will be able to illustrate well-defined sets, subsets, cardinality of a set, null sets, universal sets, union and intersection of sets with the code M7NS-IA-1. Now, let us study by looking at the objects on the screen. Look at the objects below. Are these objects familiar to you? Now, try to group them according to its kind. Let us try to answer the following question. For number 1, how many groups can you form? There are 6 groups. Some possible groups you can form are as follows. B is the set of blue objects, R is the set of red objects, S is the set of shoes, F is the set of fruits, T is the set of toys, C is the set of clothes. Number 2, does each object belong to a group? Yes. Number 3, is there an object that belongs to more than one group? Which one? Yes, and these are the shoes, fruits, toys, and clothes. This group or collection of objects is called a set. We denote each set by a capital letter. Each object in a set is called a member or an element of a set. A set must be well defined. This means that our description of the elements of a set is clear and definite. Thus, in our activity, set B is a set of objects that are blue, and set C is a set of shirt, pair of sneakers are well-defined sets. Examples of well-defined sets. Number 1, the vowels in the English alphabet. Number 2, the months of a year. Number 3, even numbers from 0 to 10. Examples of not well-defined. Number 1, group of intelligent students. Number 2, list of beautiful students in your school. Number 3, a basket of different delicious fruits. How do you describe a set? This will lead you to the set notation. Set notation. There are 3 ways to describe sets. Number 1 is the descriptive method. Number 2 is the rooster method, and number 3 is the set builder notation. The descriptive method. A set can be described by writing a description of its elements. Examples. Write each set using the descriptive method. For A is a set of 1, 2, 3, 4, 5. For B is a set of September, October, November, December. Solutions. For letter A is a set of first 5 counting numbers. Letter B is the set of months ending in ber. Next is the rooster method. A set can be described by listing all its elements within a pair of braces. Each element is separated from the next by a comma. Examples. Write each set using the rooster method. A, the set of distinct letters in the word sensitive. B, the set of colors of the rainbow. Solutions. For letter A is a set of S, E, N, I, T, V, E. Notice that when listing the elements of a set, identical elements are not repeated. For letter B is the set of red, orange, yellow, green, blue, indigo, violet. Next is the set builder notation. A set can be described by using variables. A variable is a symbol, usually a letter that can represent different elements of a set. Examples: write each using set builder notation. For letter A, we have the set of 1, 2, 3, 5, 7, etc. For letter B, we have the set of red, yellow, blue. Solutions. For letter A is a set of all x such that x is a prime number. For letter B is the set of all x such that x is a primary color. Let us proceed to the elements of a set. The phrases is an element of and is not an element of occurs so often in discussing sets that special symbols E for an element of and E with a slash for not an element are used for them. For example, if A is the set of 3, 4, 5, 6, then 3 is an element of the set A, and 8 is not an element of the set A. Example: fill in each blank with the symbol used for an element or not an element. For set A, we have the set of even numbers between 0 and 10, so the elements are 2, 4, 6, 8. And set B, with the elements of letters of the English alphabet between C and J, so the elements here are D, E, F, G, H, I. For number 1, 2 is an element of A. Number 2, 5 is not an element of set A, since 5 is not an even number. Number 3, 12 is also not an element of set A, since 12 is not between 0 and 10. For number 4, B is not an element of set B, since B is not between C and J. Number 5, G is an element of set B, and number 6, E is an element of set B. Let us continue with cardinality of a set. Cardinality of a set. Cardinality of a set, denoted by N of A, refers to the number of elements in a given set. Example: identify the cardinality of the following sets. For letter A, V is the set of vowels in the alphabet. For letter B, E is the set of 1, 3, 5, 7, 9, 11. And C is the set of students who ride a submarine to school every day. Solutions. For A, V is the set of A, E, I, O, U. Since there are 5 vowels in the alphabet, then the cardinality of set V is equal to 5. Letter B, the cardinality of set E is equal to 6. And letter C, since there are no students who ride a submarine to school every day, then the cardinality of set S is equal to 0. Notice that some sets have no elements. For instance, the cardinality of set S is equal to 0. A set with no elements is called an empty or null set. It is denoted by the symbol braces or O with a slash. How about finite and infinite sets? Finite sets. A set is a finite set if all its elements of the set can be listed down. Examples of finite sets. Number 1. Set A is the set of days in a week. So, the elements of set A are Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. For number 2, set B is the set of natural numbers between 10 and 15. So therefore, the elements of set B are 11, 12, 13, 14. Infinite sets. A set is an infinite set if not all the elements can be listed down. Examples of infinite sets. Number 1, set C is the even whole numbers. So therefore, the elements of set C are 0, 2, 4, 6, 10, etc. Note, an ellipsis is the 3 dots which indicates that the series of elements are continuous. Let's proceed with equal and equivalent sets and universal sets and subsets. Equal and equivalent sets. Two sets A and B are equal, written A is equal to B if they have exactly the same elements. Two finite sets A and B are equivalent if they have the same number of elements. Examples. State whether each pair of sets is equal, equivalent, or neither. For letter A, K is equal to the set of 5, 6, and L is equal to the set of 1, 5, 9. Letter B, M is equal to the set of red, blue, green, and N is equal to the set of green, blue, red. Letter C, O is equal to the set of 3, 4, and P is equal to the set of 7, 8. Solutions. For number 1, K and L are neither equal nor equivalent. Number 2, M and N are equal sets. The arrangement of the elements does not matter. So, M is equal to N. Number 3, O and P are not equal sets since they do not have exactly the same elements. But O and P are equivalent sets since there is a one-to-one correspondence between the elements of the sets. Universal sets and subsets. A universal set is a set which contains all the elements or objects of each set, including its own elements. It is usually denoted by the symbol U. Example. Consider the following sets. For letter A is a set of 1, 3, 6, 8. Letter B is a set of 2, 3, 4, 5. And letter C is a set of 5, 8, 9. Find the universal set for A, B, and C. Solution. By the definition we know, the universal set includes all the elements of the given set. Therefore, universal set for sets A, B, and C will be U is equal to the set of 1, 2, 3, 4, 5, 6, 8, 9. If all the elements of set A are also the elements of the set B, then the set A is called the subset of set B. If A represents any element of set A, then the definition is represented symbolically by A is an element of set A and A is an element of set B, then A is a subset of B. On the other hand, A is not a subset of B if at least one element of A is not an element of B. It is represented by A is not a subset of B. Set A is a proper subset of B, written A is a proper subset of B if and only if every element of A is also an element of B and that B contains at least one element that is not in A. Note, an empty set is a subset of every set and every set is a subset of itself. Example. Identify which of the following are subsets to each other. For A, V is equal to the set of Tuesday, Thursday, and W is the set of days in a week. Letter B, A is a set of 2, 4, 6, and B is a set of 0, 1, 2, 3, 4, 5, 6. Letter C, B is the set of birds and F is the set of flying creatures. Letter D, M is the set of 1, 2, 3, 5, and N is the set of 1, 2, 3, 4, 6, 8. Solutions. For letter A, D is a subset of W because every element of D is an element of W. Letter B, A is a subset of B because every element of A is an element of B. Letter C, B is not a subset of F because not all birds can fly like an ostrich. Letter D, M is not a subset of N because 5 is not an element of N. Lastly, let us discuss operations on sets. Operations on sets. Number 1, the union of sets. The union of sets A and B, written A union B, is the set of all elements that are in A or in B or both A and B. The word or suggests union. Example, if A is equal to the set of 1, 3, 7, 5, and B is equal to the set of 3, 7, 8, 9, find A union B. Solution. A union B is equal to the set of 1, 3, 5, 7, 8, 9. No element is repeated in the union of two sets. The common elements 3, 7 are taken only once. Example, let X be the set of A, E, I, O, U, and Y be the set be an empty set. Find union of two given sets X and Y. Solution. The X union Y is equal to the set of A, E, I, O, U. Therefore, union of any set with an empty set is the set itself. Number 2 is the intersection of sets. The intersection of sets A and B, written A intersection B, is the set containing the elements that are common to both A and B. The word "and" suggests intersection. Example, if A is equal to the set of 2, 4, 6, 8, 10, and B is equal to the set of 1, 3, 8, 4, 6, find A intersection B. Solution. So the A intersection B is equal to the set of 4, 6, 8. Therefore, 4, 6, and 8 are the common elements in both the sets. Another example, if X is equal to the set of A, B, C, and Y is equal to an empty set, find X intersection Y. Solution. So the X intersection Y is equal to an empty set. Since X and Y have no common elements, then X intersection Y is equal to an empty set. We say that X and Y are disjoint sets. Note, sets A and B are disjoint if and only if no elements of A are in B. Number 3, difference of two sets. If A and B are two sets, then their difference is given by A minus B or B minus A. A minus B is the set of all elements of A that are not in B. And B minus A is the set of all elements of B that are not in A. Examples. Let A be the set of A, B, C, D, E, F, and B be the set of B, D, F, G. Find number 1, A minus B, number 2, B minus A. Solutions. For number 1, A minus B, we have the set of A, C, E. Therefore, the elements A, C, E belong to A but not in B. Number 2, B minus A is equal to the set of G. Therefore, the element G belongs to B but not in A. Complement of a set. The complement of set A, written A complement, is a set of elements in the universal set that are not in A. Examples. Let U be the set of 1, 2, 3, 4, 5, 6, 7, 8, and A be the set of 1, 3, 5, and B is equal to the set of 2, 4, 6. Find number 1, A complement, number 2, B complement, number 3, A union B complement. Solutions. For number 1, A complement is equal to the set of 2, 4, 6, 7, 8. These elements are not in set A but are in the universal set. Number 2, the B complement is equal to the set of 1, 3, 5, 7, 8. These elements are not in set B but are in the universal set. And number 3, the A union B complement is equal to the set of 7, 8. These elements are not in A union B but are in the universal set. Now that we are done with today's discussion, I would like to remind that you have to answer all the activities and exercises found in your module. This has been Teacher Marie saying, every best decisions in life requires someone to have a critical mind and loving heart. Empower yourselves with mathematics because math matters.